Okay, for this video tutorial, we're going to look at the properties of exponents. And there are many different properties for exponents, and the first one we're going to look at is the zero power. So for the zero power, it's when you have an exponent that is zero. And a lot of times students will say, oh, I'm going to multiply and get zero. So 3 to the 0 is 0. Well, the rule is any base to the zero power is automatically 1. 3 to the 0 is 1. Negative 12 to the 0 is 1. You could have a symbol like pi, and pi to the 0 is still the number 1. Something you might want to watch out for is if you have a negative number to the zero power, be careful there, because the order of operations says, okay, first you're going to do 7 to the 0 power, and that is 1. Then you're going to make it negative, so your final answer will be a negative 1. So just be careful with your orders of operations there. Okay, so let me just scooch up a little bit here to the negative exponent. Okay, another property to look at is the negative exponent property. What happens if you have an exponent that's negative? So the rule with the negative exponent is that if you have an exponent in the, it's negative, and it means to put it in the denominator and to make it positive. So the rule is, here's an example, a to the negative fourth. So however you write that using a positive exponent is, I say, okay, it's a negative exponent, which means it now needs to be going downstairs. So it's no longer, right now it's written like this, negative a to the fourth over 1. But the negative exponent says move me downstairs, make me positive, and I become 1 over a to the fourth. In this example here, I have a negative exponent in the denominator. So if I have a negative exponent in the denominator, what it does is it moves it to the numerator and it makes it positive. So here I have a 1 divided by 3 to the negative third. So this 3 to the negative third is saying move me upstairs. So I have a 3 to the third power upstairs, and the 1 is in the denominator. It's like a reciprocal. You're flipping that fraction. My final answer is 27. Now here is an interesting example. I have a negative 4 to the negative 3. So I'm going to put it over here. I have a negative 4, and it's to the negative third power. Okay, and then in the denominator, I have a negative 2, lots of negatives in this problem, just because a lot of times we get nervous with negatives, and here's a good example so that you don't stress about the negatives. Okay, negative 2 to the negative 5. All right, so first I'm going to deal with these negative exponents. Here I have a negative 3. This negative 3 is telling my negative 4, we need to go downstairs. And here I have a negative 5. This negative 5 is telling base negative 2, hey, we need to go upstairs. So essentially what they're going to do is they're going to change places. I'll have a negative 2 to the fifth power in the numerator. As soon as it moves to the numerator, it is no longer a negative exponent. In the denominator, I have a negative 4. As soon as it moves to the denominator, it no longer has a negative exponent, and it is third power. So in the numerator, I have negative 2 to the fifth power, which is a negative 32. In the denominator, I have negative 4 to the third power, which is negative 64. When I simplify those, a negative divided by a negative becomes a positive, and 32 divided by 64 is really the same as 1/2. Okay, another rule that we're going to look at here is called the product rule. And the product rule tells us that if you have same bases, a B and a B, and I'm multiplying them together, my exponents will be added together. So here I have it again right here just to help us remind ourselves. I have a b to an exponent times a b to a different exponent is actually the same as b to the two exponents added together. So a to the third times a to the second times a. If there's no exponent there, put a little 1. That'll just keep that place and you won't think 0. So sometimes we think a to the 0, but remember a to the 0 is 1. A to the 1 is a. So put a little 1 up there. Okay, so a to the third times a squared times a to the first is the same as a to the 3 plus 2 plus 1. Essentially, again, when I have same bases, I add my exponents and my final answer is a to the 6th power. Let's look at this problem down here. Here I have some numbers, -2 and a -3. Okay, I can combine a -2 and a -3, and I'll just put them out front here. Okay, then I look, I've got some x's, an x to the third, an x to the first, and an x to the second. So it looks like I've got 3 different x values. They're all being multiplied together. And when I multiply same bases, the rule is that I add the exponents. So I have x to the third, and then I have another one, and I have 2 more. So it's going to be x to the 3 plus 1 plus 2. We add the exponents. For my y, I have a y to the 1 right over here. I have a y to the 5 right over here. And I have a y squared right over here. Again, I'm multiplying same bases, which means I add my exponents. Alrighty, so we are going to now combine numbers with numbers, x's with x's, and y's with y's. A -2 times a -3 is a +6. So my numbers are all taken care of. When I add all my exponents, I have a 3 plus 1 plus 2, which is a 6. So I have x to the 6th power. When I add all my y exponents, I have a 1 plus 5 plus 2, which leaves me with the final answer of 6, x to the 6th, y to the 8th. Now the quotient rule is similar to the product rule, but instead of multiplying, we are going to be dividing. When I divide same bases, instead of adding my exponents, like the product rule, we subtract the exponents. And a lot of times when I taught this in school, I would say to the students, who wins, top or bottom, and by how much do they win? So we're going to do it 2 different ways, and you can choose which way you like the best. So notice here I have same bases of a, okay, and then I have one has a 7 and one has a 2. Because I'm dividing, I will subtract the 2 from the 7. Okay, I take away the bottom number and I have a positive number for the upstairs number. B to the third is my next power in the numerator. B to the 7th is in the denominator. So what I can do there is I write my base b and I do a 3 take away 7. Okay, and then I will rewrite this, as a to the 7 minus 2, which is 5, and b to the -4. Remember, the negative exponent tells me, move me, flip me. So I have an a to the 5th in the numerator, and I have a b to the 4th in the denominator. By playing the who wins game, I can look just quickly at my fraction and I can say, okay, out of these a's, the top wins by 5. And that's where I get my top answer of a to the 5th. And looking at these 2 values here, the b's, the bottom wins. By how much? He wins by 4. And that's where I get my b to the 4th down here. The last property that we're going to have a look at here is called the power rule. And the power rule is really handy when you're dealing with exponents of powers or exponents. The rule is any base to an exponent, you multiply the two exponents. So I'm going to erase that one more time. Okay, so here is an example. I have u squared, so it's an exponent. And I have v to the third, which is another exponent, and they are to the fourth power. This means I have 4 packages of u squared v cubed, u squared v cubed, u squared v cubed, u squared v cubed. I have 4 of those. And instead of writing them all out, what I can do is I can say, okay, take my first base to the 2 times 4 power times my second base to the 3 times 4th power. This is equal to u to the 8th, v to the 12th. So when I have a power to the exponent, we multiply the exponents. Here's another example that we're going to do, and I like it because it involves division, but it also involves the power on the, the exponent on the outside and number bases on the inside. This exponent goes to every base on the inside. The 6 becomes squared. The x has a cube, but it now also has a square. The 5 becomes squared. The y has a square, and now it's going to be squared again. So as a reminder, this exponent here goes to every base inside the parentheses. It goes to the 6, and it goes to the x. It goes to the 5, and it goes to the y. So let's simplify this. 6 squared gives me 36. X to the third squared. We multiply our exponents, and I get x to the 6th. Oops, this is a 36, pardon me. 5 squared is 25. I have a y to the second squared, so I multiply my two exponents, and I get y to the 4th power.